Okay, so another type of proofs that happen to show up a lot are ones with fractions. When you get these prove, they're not going to say anything but this. It's just going to say like verify the identity or prove this. That's it. It's not going to say prove this using distributed property or separating the fractions or completing the square. Like, doesn't tell you any of that. So you need to be able to identify these, okay? So here's a couple of examples that include fractions on, and we're going to prove, okay? So same thing. We're going to ask ourselves, which one is the grosser side? And this one you could actually argue either one because this one has squares and subtraction, but I'm going to go with a fraction because I'm guessing you said that too, because I know fractions are very scary sometimes. Okay, so if I have a binomial on top, which remember means two terms being added or subtracted, with a denominator, I could separate this into two fractions, okay? Just like if I had, let's go, x minus 2 over 3. This could be the same thing as x over 3 minus 2 over 3. And you're probably thinking like, well, that looks even less simplified than it did there, which is fine. We just want to work with this and start rewriting. Just start, and then we'll figure out where to go from there, if it works or not, okay? So following this kind of model, let's do this. So we're going to write it as two fractions. Tan t, any variable, I don't think we've seen a t yet, over that whole denominator. Do not skip steps on this, guys. That will make for a lot of mistakes and frustrations. And then same denominator there, sine t, cosine t, okay? And it's supposed to equal this guy. If you just want to write equal and then a blank, that's fine too. And notice I'm always working vertically. I hope you do too, and not horizontally in math, because that's just not how we show our work usually. Okay, well, that's fine and dandy, but now I got something even grosser. But remember, whenever you get stuck, what are we supposed to do? Right, in terms of sines and cosines, I hope is what you answered. So in this case, we're going to go ahead and rewrite tangent, and tangent is sine t cos t. I'm going to put this in parentheses just to kind of keep it like that's that. Divided by, you don't have to by any means, sine t cos t minus, I'm going to rewrite this in terms of sines and cosines. So that's the opposite of this guy. So we're going to go cosine t sine t over sine t cosine t. Okay. Okay, so now it looks like we have a complex fraction, a fraction within a fraction. So when we have a fraction within a fraction, it's just division. And how do you divide fractions? We multiply by the reciprocal. So I'm going to make these into fractions, and I'm going to multiply both by the reciprocal. So 1 sine t cos t, that looks nice. 1 sine t cos t. Okay, so these ones go away. Yay. And then I got to do it over here, which is the same denominator. So sine t cos t over 1 times same guy. Goes cancel, cancel, cancel. Okay, so now let's rewrite what we have. I'm still going to write that equal sign over here, and if you want to rewrite that function, go for it. It's probably the better habit to have when doing these. Okay, so all of this nasty denominator is gone. So now I'm just working with the numerator. Multiply fractions straight across. So sine t times 1 is going to be sine t. Cosine times sine t times cosine. That's going to be cosine. Cos times cos is cos squared t. Remember, it's not the t squared, it's the cosine function. Times sine t. And if you wanted, you could have put sine t times cosine squared t. That's fine, commutative property. So I did top and then bottom, minus, same thing, top, and then bottom, sine t times sine t, that's sine squared t times cosine t. Okay, and I want this to become secant squared t minus cosecant squared t. Well, I got some squares. That's looking like the right direction, right? All right, now looking at the fractions, we can cancel some stuff out because it's a multiplication. If it was addition or subtraction, we can't cancel it out. Feel like a broken record. Hopefully you guys are like, yeah, duh, we know that. Cos cancels out. Sine squared t. And we want to get secant squared t minus cosecant squared t. Oh, I feel like I'm so close. Look, there's a minus, square terms. Oh, what's this reciprocal identity? That's secant squared minus the reciprocal identity of this guy, cosecant squared. Oh my goodness, guys. It's like almost as exciting as Christmas morning. Got it. Boom. Okay. Let's try another one. Okay. Now these ones are a little bit more difficult because you can't like break it into two separate fractions like we did before. And there's not like a more gross side. Okay. This denominator is a binomial with a minus in it. And if you had a binomial with a plus or minus in it, denominator, binomial, so a term plus or minus another term, you want to start with that side. Okay, so this is the side that I do want to start with. I can use the conjugate on this one. And you're probably thinking that sounds familiar from forever ago. So let's take a minute to look back at that. When we had a radical in the denominator, we had to multiply by the conjugate to get rid of this. And the conjugate is just the term with the switched inside sign. And then we would just FOIL it out. So we would get 1 plus root 3, and then down here we would get 1 times 1, positive root 3, negative root 3, if I multiply those guys, and then negative root 9, which is 3. My radicals cancel out, which is what the whole reason why we do conjugates. So it goes like we did the conjugate to get rid of the nasty radical in the denominator, which we can't have. It's not simplified form. Okay, but we can do this because this over this is 1, just like 5 over 5 is 1. Anything over itself is 1. So we can do the exact same thing here. We can multiply top and bottom by the conjugate of this guy. So we're going to say, let me rewrite that in green. So we're going to say what we're given here, cosine x, 1 minus sine x. So I'm going to start with this side, and I'm going to multiply by the conjugate. So it's going to be 1 plus sine x, 1 plus sine x. Okay. These don't cancel out. We have to do FOIL them out. Okay. So we're going to get cos times 1 is just 1 cos plus cos x times sine x. Can't do anything with that guy. And then divided by, we got to FOIL out this bottom. 1 times 1, 1 times sine, negative sine times 1, negative times a positive is a negative, sine times sine is sine squared. And I'll rewrite what we want, just so we don't forget what we're going for here. Okay, plus sine, minus sine. Those cancel out, which is the whole reason why we did the conjugate, okay? So we're left with the numerator. We can't really do much over there. And then we have 1 minus sine squared x. What's 1 minus sine squared x? Squared. We got to do Pythagorean theorem. So if you look at your identities, you have sine squared plus cosine squared equals 1. So can I get it to be 1 minus sine squared? Yep.
It was really just because it was
so cosine squared theta equals 1 minus sine squared theta. So that's what that little note means, is we can manipulate the Pythagoreans to get what we want. So we can rewrite that as cosine x plus cosine x minus sine, or not minus, sorry, times sine x, all over cosine squared x. Looks good. Okay. I'll give you a minute to look at it and see if you can think of what we should do next. I like that we both have a plus sign. That looks good. And then, oh, we almost have cosine squared down here. So do you see it? Every single term, remember terms are separated by plus or minuses, not multiplication. Every single term has a cosine. So we can cancel out a cosine. The more mathematically correct thing we would be doing is factoring out a cos. So let me just do that one quick. Okay, and then we can cancel cos and the square out. So we get 1 plus sine x over cos x. And that is what we need. So you didn't have to do that factor out if you didn't see that. You could have done what I like to call the V cancel. So let me show you right here. So on this guy, we see is cos, cos, cos in each term, right? So we could have canceled out this cos, canceled out this cos, and then canceled out the square of this guy. When everything cancels out, it's 1. So that would have been 1 sine x over cosine x. So you didn't have to show this factored out cosine if you didn't see it that way. Let me see if we got another one on that guy. We do not. That is it for identities with fractions. Stay tuned for more.